You think time travel is a fantasy because you think you understand time. You've watched clocks tick. You've waited in lines. You've felt boredom stretch and excitement compress. You remember yesterday, and you plan for tomorrow. It feels obvious. Time moves forward. End of story. That feeling is the trap, because the moment you say time travel isn't real, what you're really saying is that time itself has a built-in direction, a built-in structure that forbids deviation. You're claiming the universe enforces a one-way rule, not technologically, not practically, fundamentally. And physics does not say that. In fact, physics does something far more unsettling. It removes almost everything you think you know about time and replaces it with something colder, more mechanical, and much less interested in your intuition. Let's start where the confusion always begins, with the idea that time flows, that it moves like a river, carrying you from the past into the future. This image feels natural because your brain experiences change sequentially. One moment follows another. But physics does not describe time that way, not even a little. In physics, time does not flow. It does not move. Nothing pushes you through it. Time is a coordinate, a label we assign to events to keep track of order. Before, after, simultaneous. That's it. Time is bookkeeping. This is already enough to make people uncomfortable because it means the thing you feel most directly is not fundamental. Your sense of time passing is not a property of the universe. It's a property of your nervous system. A pattern recognition tool built for survival, not truth. Once you accept that, something strange happens. The laws of physics stop caring which direction time points. Almost every fundamental equation works just as well backward as forward. If you reverse time in the math, nothing breaks. The equations don't protest. They don't collapse. They don't label one direction as special. That should bother you, because if the laws don't enforce a direction, then the idea that time must only go forward is coming from somewhere else. And that somewhere else is not physics. People usually reach for entropy at this point, and we'll get there. But before we do, we need to talk about relativity, because this is where time stops being an abstract argument and starts doing measurable violence to common sense. Special relativity tells us that time and space are not separate things. They are fused into space-time. You do not move through time independently of space. You move through space-time, and how much of that motion goes into time versus space depends on how fast you're moving. This isn't philosophy, it's measurement. Move fast enough, and your clock runs slower than someone else's. Not because the clock is broken, not because of illusion, because time itself behaves differently along different paths through space-time. We test this. We correct for it. Satellites rely on it. Particles rely on it. The universe does not negotiate. This alone already gives you time travel. If you move fast enough and come back, less time has passed for you than for everyone else. You have traveled into the future, not symbolically, literally. This is not theory, it is experimental fact. People are comfortable with this because it feels polite. You're still moving forward. You didn't disturb anything, you just took a shortcut. Fine. But the moment you ask about going backward, discomfort spikes. And not because physics changes, because intuition panics. So let's ask the question cleanly, without movies, without machines, without drama. Does physics forbid backward time travel? No. General relativity allows space-time to bend, twist, and fold. And when it bends enough, the equations permit paths that loop back in time. These are called closed time-like curves. The name sounds technical, but the meaning is simple. A path through space-time that returns you to an earlier time. These solutions are not rare curiosities. They fall straight out of Einstein's equations. They have been known for decades. Rotating universes, extreme gravitational configurations, certain wormhole geometries. The math allows them. This is where people retreat. They say these solutions are unrealistic. They require exotic matter, infinite cylinders, conditions we can't create. Maybe. But notice what just happened. You moved from impossible too impractical. Physics already crossed the line. If time travel were fundamentally forbidden, the equations would block it outright. They don't. They permit it and move on. So now we arrive at the thing everyone reaches for like a weapon. The paradox, the grandfather paradox. You go back in time and prevent your own existence. Contradiction. Case closed. Except physics does not resolve contradictions by banning them emotionally. It resolves them by restricting which histories are allowed. There are only two consistent outcomes. Either time travel is impossible, which the equations do not support, or your assumptions about causality, choice, and history are wrong, and this is where the ground starts to give way. One option is self-consistency. If you go back, you were always part of the past. You cannot change it, because what you do was already included. You don't kill your grandfather. Not because something stops you dramatically, but because a history in which you succeed is inconsistent with the fact that you exist to attempt it. This feels conspiratorial. It feels like the universe is watching you. It isn't. It's doing something simpler. It's selecting only globally consistent solutions, the same way physics always does. The other option is branching histories. You go back and create a new branch. No contradiction. No erasure. Just multiplicity. Many timelines instead of one. Neither option feels comforting. Both are allowed. And neither requires breaking the laws of physics. At this point, people want to call this philosophy. But it isn't. It's geometry. It's what happens when you take space-time seriously instead of narratively. Time travel is not forbidden by physics. What's forbidden is your old mental model of time. And that's the part no one tells you up front. At this point, most people think they've found solid footing again. They say, fine, maybe the equations allow strange paths. Maybe paradoxes can be patched with self-consistency or branching universes. But none of this proves time travel is real. It's just math, elegant math, disturbing math, but still math. Until something happens in the world, it's all theoretical. This sounds reasonable. It's also where the misunderstanding deepens, because the claim that time travel is only theoretical assumes that time itself is something we observe directly. It isn't. What we observe are clocks, particles, signals, and changes. Time is inferred from how those things behave, and those behaviors already violate the picture you started with. Think about what you are actually measuring when you measure time. You are counting cycles of some physical process, a swinging pendulum, a vibrating quartz crystal, an oscillating cesium atom. Time is not something flowing past those processes. Time is what you call the order of those oscillations. Now ask a more dangerous question. What happens if two clocks don't agree? Not because one is broken, but because physics says they shouldn't. This is not hypothetical. It happens constantly. Clocks at different altitudes tick at different rates. Clocks in motion tick at different rates. Two observers can disagree on how much time has passed between the same pair of events, and both can be correct. This is not philosophical disagreement. It is operational. Each clock records its own proper time, and there is no universal referee to declare one right. This already means that time is not a single global quantity. It is local, path-dependent, sensitive to motion and gravity. That alone should make the phrase, the past, feel less solid than it used to. Now push that idea just a little further. If time depends on the path you take through space-time, then different paths can connect the same events in different temporal orders. This is not speculation. This is exactly what relativity predicts. Events that are simultaneous for one observer are not simultaneous for another. What one observer calls past, another can call future, depending on their motion. You are already living in a universe where temporal order is not absolute. Once that door is open, the idea that some paths might loop is no longer shocking. It's an extension. Now let's return to entropy, because it keeps coming back like a nervous tick. People insist that entropy gives time its arrow, and therefore time travel must be fake. But this confuses two different things: the direction we remember, and the direction the laws enforce. Entropy explains why you remember the past and not the future. It explains why eggs break and don't reassemble. It explains why information spreads. It does not impose a global prohibition on space-time geometry. A closed, time-like curve does not require entropy to decrease everywhere. It requires a space-time structure in which a local observer's proper time loops. Along that loop, entropy can increase monotonically. Nothing breaks. No eggs unbreak. No memories reverse. This is why the entropy objection always fails when you look closely. It assumes time travel means reversing the universe. It doesn't. It means revisiting regions of space-time that already exist in the block. The universe does not rewind. You just take a different route. Now consider something even more unsettling. If time travel is allowed by the same framework that correctly predicts black holes, gravitational waves, and time dilation, then banning it would require a new principle. A principle that overrides general relativity under specific conditions. A principle that has never been observed. Physicists have tried to invent such principles. Chronology protection, cosmic censorship, quantum instability, none of them are proven. Some help in certain models, others fail in others. There is no universal veto, which means that, as of now, the honest position is not that time travel is impossible. It is that we do not know whether the universe realizes the configurations that permit it. That distinction matters, because saying we don't know if it happens is very different from saying it cannot happen. Now let's flip the perspective, because this is where the title stops being provocative and starts being literal. Time travel is real, not because someone built a machine, but because time itself is already behaving in ways your intuition labels as travel. Every time a clock ticks at a different rate than another clock, time has diverged. Every time two observers disagree on what is simultaneous, time has fractured. Every time a particle survives longer because it is moving fast, it has effectively traveled into the future. These are not metaphors, they are measurements. You are surrounded by evidence that time is flexible, local, and path-dependent. You just don't call it time travel because it happens quietly and obeys equations instead of narratives. Feynman once emphasized that the problem with understanding time is not the math, it's the pictures we insist on using. We imagine time as a line because lines are easy, but space-time is not a line, it is a geometry. And geometries can do things lines cannot. Once you stop asking whether time behaves the way you feel it should, and start asking how clocks and signals, by now the pattern should be impossible to ignore. Every time you try to pin time down, it slips out of the shape you expect. You try to treat it as universal, it becomes local. You try to treat it as absolute, it becomes relative. You try to treat it as flowing, it turns into bookkeeping. You try to forbid it from looping, and the equations refuse to cooperate. This is the point where people often make a final appeal to intuition disguised as prudence. They say, even if time isn't what we think, even if relativity and entropy and geometry allow strange paths, surely reality itself must be simple underneath. Surely the universe wouldn't allow something as destabilizing as time travel. That word, surely, is doing a lot of work there. Physics has never promised simplicity in the way humans mean it. It promises consistency. And consistency does not care whether the result feels destabilizing. Black holes destabilized reality. Quantum mechanics destabilized reality. Relativity destabilized reality. Each time, the universe kept going, indifferent to how strange things felt from the inside. Time travel belongs to that same category. It is destabilizing only if you insist on holding on to a picture of time that physics has already discarded. Now let's pull everything together, because the mistake people make is thinking this argument is about a single exotic possibility. It isn't. It's about what kind of universe you live in. You live in a universe where time is not a background stage. It is not an invisible conveyor belt. It is part of the geometry of reality. It stretches, contracts, tilts, and depends on motion and gravity. There is no universal present, no master clock, no global ordering of events that everyone must agree on. Once that is true, time travel stops being a special add-on and becomes a question of geometry. Can space-time curve in ways that allow loops, The equations say yes. Do paradoxes arise? Yes. Do they destroy consistency? No. They force it. The grandfather paradox doesn't show that time travel is impossible. It shows that naive causality is incomplete. Information loops don't violate physics. They violate storytelling instincts. This is the hardest thing to accept because humans experience life as a narrative. Beginning, middle, end, cause, then effect. Physics does not guarantee that structure. It only guarantees that the math closes. You can see this clearly if you stop thinking about time travel as a human activity and start thinking about it as a property of space-time itself. The universe does not need travelers. It does not need machines. If its geometry allows closed paths, then events already influence each other in ways that do not fit a simple, linear story. And if the geometry does not allow them, then time travel does not occur. Not because it is banned, but because the shape of space-time does not permit it. That's the real lesson. Physics doesn't issue moral rulings. It doesn't say this would be too confusing. It says, given this structure, these paths exist. So when you hear time travel is real, the claim is not that someone is hiding a device. It is that the framework we already trust does not enforce the intuitive rules you thought were fundamental. Time behaves nothing like your internal clock suggests. And here's the quietest, most unsettling part of all. You don't need time travel to break your intuition about time. That break already happened. You just live in a regime where the effects are small. Low speeds, weak gravity, short distances. In that narrow slice of reality, time behaves almost the way you expect. Almost. Physics is the art of discovering how thin that almost really is. Time travel feels radical because it pushes you outside your evolutionary comfort zone. But so did the idea that the Earth moves. So did the idea that matter is mostly empty space. So did the idea that cause and effect are probabilistic. Each time, the universe turned out to be stranger than the story we told ourselves. And each time, the story lost. Time isn't what you think because it was never built to be what you think. It was built to be measured, compared, transformed, and understood mathematically. When you do that honestly, without protecting intuition, the conclusion is unavoidable. Time is flexible. Time is local. Time is geometric. And time does not come with a built-in guarantee that it only points one way forever. Time travel is not a violation of physics. It is a consequence of taking physics seriously. The real violation is pretending that your intuition about time was ever a reliable guide to the structure of reality. And that, more than any paradox, is what actually collapses. There's a quiet mistake hiding underneath nearly every objection to time travel, and it's subtle enough that most people never notice they're making it. The mistake is assuming that physics is supposed to match how reality feels from the inside. It isn't. Physics does not begin with experience. It begins with measurement, with clocks, rulers, detectors, signals. It asks how these things behave under different conditions, and then builds a mathematical structure that predicts those behaviors consistently. If the structure clashes with intuition, intuition loses. Every time. Time travel feels outrageous because your experience of time feels intimate. You feel yourself aging, you feel waiting, you feel anticipation. But none of that is time itself. That's cognition layered on top of physical processes. Chemistry, neurons, memory formation, pattern recognition. All of it happening inside a system that evolved to survive, not to describe space-time accurately. Once you separate those layers, the outrage evaporates. Physics does not say time moves forward. It says clocks behave in specific ways along specific paths. It does not say the past is gone. It says records exist in certain configurations. It does not say the future is open. It says probabilities evolve according to rules. The language you use to talk about time is doing more harm than the math ever did. This is why Feynman-style explanations hit so hard. They don't give you a new metaphor. They take metaphors away. They force you to stop asking the universe to explain itself in terms you already understand. When you do that with time, the result is unavoidable. Time is not a universal river. It is not a single line. It is not an absolute background. It is not even globally ordered. It is a dimension in a geometric structure that responds to motion, energy, and gravity. In such a structure, paths that loop are not heretical. They are geometric possibilities. The only reason they feel forbidden is because your everyday experience has trained you to expect a simpler world. A world where before always comes before, and after always comes after. Everywhere, for everyone, that world does not exist. And here's the part people rarely sit with long enough. Even if backward time travel never happens in our universe, even if no closed time-like curves are ever realized, the conclusion does not change. The reason it doesn't change is because the impossibility would be contingent, not fundamental. It would mean this universe happens not to realize those geometries, not those geometries are forbidden. That distinction is everything, because when something is forbidden by law, you can stop thinking about it. When something is merely unrealized, you have learned something deeper about how reality is structured. Time travel is real in the same sense that curved space was real before we detected gravitational waves. In the same sense that black holes were real before we photographed one. In the same sense that time dilation was real before we flew atomic clocks on airplanes. It is embedded in the framework that already works. The paradoxes are not warnings, they are signposts, telling you exactly where your intuitions stop applying. And if you zoom out far enough, the entire debate takes on a different shape. For most of human history, time was something you counted by watching shadows move, then pendulums, then springs, then atoms. Each step stripped away a layer of storytelling and replaced it with precision. Each step made time less human and more physical. Time travel is not a leap forward from that process. It is the continuation. You don't need to believe in time machines. You don't need to believe in visitors. You don't need to believe in rewriting history. You only need to accept what the equations you already trust are telling you. Time is not what you think. And because it is not what you think, the rules you assume it must obey are not rules at all. They are habits. Physics does not run on habit. So when you hear time travel is real, understand what is actually being claimed. Not that the past is fragile. Not that the future is accessible. Not that paradoxes reign. What's being claimed is something simpler and far more unsettling. That the universe does not organize itself around the way your mind experiences time. That causality is a pattern, not a commandment. That the flow you feel is not written into the fabric of reality. And once that clicks, the idea of time travel stops sounding like science fiction and starts sounding like what it really is.